Hello everyone, my name is Mohit Gupta and I welcome you to my YouTube channel Chem Fundamentals. In today's video, we are going to discuss about Chatelier Principle. This is part 5 of the equilibrium. The rest of the parts are given in the description box as well as iCard over here. So without further delay, let's get started. So this is the table of contents and today we are going to discuss what is Chatelier Principle, how equilibrium is affected by the change in concentration, by the change in temperature, how it is affected by the change in pressure, and as well as with the change in volume. So first of all, we'll be discussing what is Le-Chatelier principle. So Le-Chatelier principle says if a system is in equilibrium and any change in concentration, any change in temperature, or any change in pressure is imposed over it, then equilibrium shifts in such a direction or equilibrium shifts in such a way that it could counter the change imposed. What does it mean? It means if you have a reaction and it is in equilibrium, then if you carry out any of the change, such as change in concentration, if you add any of the reactant or remove any of the product, if you increase or decrease the temperature, if you increase or decrease the pressure or volume, then equilibrium get disturbed. During this disturbance, equilibrium shifts in such a way that it could counter or it could undo the change that we have made or we have imposed over it. So let us understand a little bit more about it. So first of all, we'll be discussing the effect of change of concentration. So if I have an equilibrium reaction and I'm going to change its concentration, maybe the concentration of reactant or the product, let's see how it goes. So I'm taking an example of A plus B is giving me C plus D. Here, A and B are the reactants, whereas C and D are the products. So I have made this table where first of all I have written in the column 1 change. What kind of change I'm carrying out? How does it affect the reaction? Next is how is equilibrium is going to respond? What kind of reaction we are getting from the equilibrium? The response of equilibrium, and at the end the direction of the equilibrium. So let's discuss it in details. First of all, addition of A and B. So I have reactants A and B, and if I'm adding more of A and B, any of the two or both of them, so if I increase the concentration of A or B, then what would be the effect? The concentration of A and B would increase. Now the equilibrium will get disturbed. During this disturbance, what will equilibrium's response? So, as I said in the definition, equilibrium will try to undo this change. So, here we have increased the concentration of A and B. So, how equilibrium will respond? It will try to decrease the concentration of A or B. So, if we increase the concentration of A and B, equilibrium will try to decrease it. And how it will decrease it? It will shift to the forward direction, like it will allow A and B to react with each other so that it can form the product C and D. In this way, the reaction will shift to the forward direction and the concentration of A and B would decrease. Next, if I add C or D in this same reaction, then what would be the effect? The concentration of C and D would increase, obviously. Now, since the concentration of C and D has increased, what would equilibrium will do? Equilibrium will try to decrease the concentration of C and D, and in order to do so, it will shift the equilibrium toward the backward directions. The next change is removal of A and B. So if I remove both the reactants or one of the reactant, the concentration of A and B would decrease. Now what would equilibrium do? Equilibrium will try to increase the concentration of A and B. And how to do so? It will allow the C and D to react so that it could form A and B. So the equilibrium will shift in the backward direction. Similarly, if I want to remove C or D, if I remove one of the product, then the concentration of product will decrease. What would equilibrium do? Equilibrium will try to increase the concentration of C and D, and to do so it will shift the equilibrium in the forward direction. So if you want to complete one of the reaction, what would be the best way to complete it? The best way is to remove one of the product. So let's understand more with the help of an example. Here I have taken Fe3 plus ion, which is yellow in color, Then if I add SCN negative ions, which is colorless, the solution become a red color, and the complex that is formed is FeSCN2 positive. Now I have taken a conical in which I have taken FeCl3 or any of the salt. Now on adding SCN to this conical, what would happen? A blood red color solution will form. This solution contain FeSCN2 plus as well as Fe3 plus and plus SCN negative. Since red color has higher intensity, so it will mask the yellow color and will found a this colored solution. Now we have this conical where all these three species are in equilibrium. There is four cases that we'll be discussing. Case 1. If I add FeCl3 to this solution, if I add FeCl3, then the concentration of Fe3 ion would increase. If this increase, the equilibrium will shift in the forward direction so as to decrease the concentration of Fe3 plus ion. And in order to do so, the concentration of FSCN2 positive will increase, and which results in the increase in the intensity of this color, blood red color. So the color of the solution become blood red to brown. Next is the case if I'll add KSCN. So this is also a reactant. So here what I'm doing is I'm increasing the concentration of reactant. So on increasing the concentration of reactant, the equilibrium will shift towards the product side and the intensity of the color would also increase. The third case is if I'm adding the product. So if I'll add more of the product, this product will decompose to form the reactants and the concentration of this will decrease, and on decreasing this, the color intensity of this conical flask would decrease and we'll get somewhat an orange color solution. Next move to the case 4 where I have taken sodium fluoride. So since sodium fluoride is nowhere in the reaction, it would be a very different case where we are not able to find out what is going to happen. What actually happens is F negative reacts with the iron 3 plus to form a precipitate. Now on forming the precipitate, the Fe3 plus ion is no longer available for the reaction. If that is the case, the concentration of Fe3 plus ion will decrease. So since the concentration of reactant decreases, the product will decompose back into the reactant and the intensity of the color would decrease. So we'll get a yellow color solution. Next, we talk about the change in temperature, effect of change in temperature. So in order to study the effect of change in temperature, we have to consider two type of reaction. One is exothermic and other is endothermic. Endothermic are the reaction where energy is absorbed to carry out a reaction, whereas in exothermic reaction, the energy is released during a reaction. So if you have taken a RB, in exothermic reaction, the RB will become warm. Whereas in case of endothermic reaction, the RB in which you are carrying out the reaction will become cold. So in case of endothermic, I have taken A plus B a reactant to give C plus D, and since it is absorbing heat, so I can write it on the reactant side. In case of exothermic, since heat is released during the reaction, so I can write heat on the product side. Now this is a kind of a trick. I have seen many of the students struggle while finding out where the equilibrium will shift in case of temperature. So what you have to do for endothermic reaction, write down the heat on left hand side on the reactant side. For exothermic reaction, just write down the heat on right hand side. And how you find out whether it is exothermic or endothermic? With the help of the sign of the heat. So enthalpy of formation or enthalpy of the reaction. If it is negative, then it is exothermic, and if it is positive, means it is absorbing energy, it would be endothermic. So let's discuss the endothermic reaction first. So if I increase the temperature, now the amount of heat would increase on the reactant side. So since it is larger in concentration or larger in amount, what would happen? The equilibrium will shift in the forward direction so as to decrease the amount of heat on the reactant side. And in that case, heat is increased on left hand side, equilibrium will try to decrease the heat on left hand side, and in order to do so, the equilibrium will shift in the forward direction. The next case is if I'll decrease the temperature. So on decreasing the temperature, heat decreases on left hand side. Obviously, if I'm decreasing the temperature, the heat on left hand side would be lesser. So in that case, The C and D will react with each other to form the reactant backs, and the equilibrium will shift towards the backward direction. Now we'll apply the same concept here. So in case of exothermic reaction, the change is if I'm increasing the temperature, the amount of heat is increasing on the product side, and the response of equilibrium would be it want to decrease the concentration, or it want to decrease the amount of heat on the product side, and in order to do so the product will absorb this energy and will get converted into the reactant back. So equilibrium response would be try to decrease the heat on right hand side, and the direction of equilibrium would be backward. If I decrease the temperature, the heat on right hand side would decrease, and in that case equilibrium will try to increase the heat, and in order to do so the equilibrium will shift in the forward direction. This is very simple concept. Next we'll be talking about the effect of pressure and volume. This effect is most prominent in gases equilibrium. So if you want to increase or decrease the pressure or volume, the major effect is shown by the gaseous equilibrium, or the equilibrium that involves gaseous molecules. For equilibrium having only liquid and solid phases, only negligible effect is observed. So in case of liquid and solid, not much effect is observed. Why? Because liquid and solids are not much compressible as compared to the gaseous molecules. Gaseous reactant and product are super compressible. So if you increase or decrease a little bit of pressure or volume, a large amount of change can be observed in case of gaseous molecule. Okay. So let us understand. I have taken an example. A2 gas plus B2 gas is giving me A2B2, which is the product. All of them are in gaseous state. So I have made this diagram. I have taken a container which contain A2 molecules, B2 molecules and A2B2 molecule. Attached a piston here, and if I provide an external pressure onto it, the pressure will increase. Since pressure is inversely proportional to the volume, if I increase the pressure, the volume of the container would decrease. So let's consider this. Initially I have 3 molecule of A2 and 3 molecule of B2, and initially there was 0 molecule of A2B2 because reaction has just started. So once it reached to the equilibrium, it has 2 molecule of A2, 2 molecule of B2 and 1 molecule of A2B2. So you can see here that you have 2 molecule of A2, 2 molecule of B2 and 1 molecule of A2B2, and which means that this vessel is at equilibrium right now, or this reaction is at equilibrium right now. Now if you increase the pressure, what would happen? The volume would decrease. Now in case the volume decreases, these A2B2 molecule would react with each other and they will convert into the product A2B2. Here you can see that. So 2 molecule of A2 react with the 2 molecule of B2 to form 2 molecule of A2B2, and now in the final stage you have 0 molecule of A2, 0 molecule of B2 and 3 molecule of A2B2. Now you can see here A2 B2 are occupying less volume, okay, and on increasing the pressure the volume is already very less, so this equilibrium is sustainable. So in this case we can say that equilibrium moves in that direction where number of gaseous moles are less. So here we can say we have 1 mole, and here we have 1 plus 1 2 mole. So on reactant and reactant side we have 2 moles of gaseous molecule, whereas on the product side we have 1. So on increasing the pressure volume decreases, and as the volume decreases the equilibrium moves in that direction which has less number of gaseous molecules, so that molecule can occupy lesser amount of space. So if pressure will decrease, the volume will increase, and if volume increase, the equilibrium will shift in such a direction where the number of molecules are more in on gaseous hand. If pressure will decrease, then equilibrium will try to shift in that direction which has more number of gaseous molecules. Why? Because more number of gaseous molecules means more volume, and if you are decreasing the pressure, which means if you are increasing the volume, so large number of molecule can be stabilized in larger volumes. Let us understand with one more example. N2O4 is decomposing in twice of NO2. Both are gases. The number of molecule on reactant side is 1 and on the product side is 2. So if you increase the pressure, what would happen? Equilibrium will shift in that direction which has lesser number of gaseous molecules, so it will move in the backward direction. On decreasing pressure, the reaction will move in forward direction. So if you are decreasing the pressure, the volume would increase and the equilibrium will shift in the forward direction, because now two molecules can occupy more volume and you have a larger amount of volume available, so the reaction will move in forward direction. Let's take one more example. This is the Haber's process where we are trying to prepare ammonia from the elements like N2 and thrice of H2. So on left hand side we have 4 moles of gases, whereas on the right hand side we have only 2. So on increasing the pressure, the reaction will move in forward direction. Why? Because in forward direction we have lesser amount of molecules and they can occupy lesser volume. Whereas if you decrease the pressure, the volume increases and the equilibrium will shift in that direction which has more number of molecules, gaseous molecules. So reaction will move in the backward direction. I hope it is clear to you. Next is effect of volume. So we have discovered that pressure is inversely proportional to the volume. Whatever the effect of pressure happens, it is reverse of the effect of volume. So pressure is inversely proportional to volume at constant pressure. So P is inversely proportional to V. So on increasing pressure, volume decreases, or decreasing pressure, volume increases. So the effect is same as compared to the pressure but is in reverse direction. At low pressure, the pressure is low, which means we have larger volume. So if we have larger volume, the equilibrium will shift in that direction which has larger amount of gaseous molecule. And if the pressure is high, we have lesser amount of volume available. If the volume is less, the equilibrium will shift in that direction which has lesser amount of molecules, gaseous molecule. Okay. So volume is directly proportional to the number of molecules. If we have lesser volume, lesser number of molecules. If we have larger volume, more number of gaseous molecule. Okay. If you are getting confused in this kind of question, this kind of conceptual question, what you do, you just write down the equation. Just write on the reactant it has more number of molecule or less number of molecule. Then apply it with the volume. If volume is large, the reaction will move in such a direction where number of molecule are large. If the number of molecule is less, the reaction will move in that direction which is now lesser number of molecule. And for pressure, just inverse it. So this is it for the today's video. If you like this video, then please hit the like button and also subscribe if you aren't a subscriber. Please also recommend this video to your friends. So this is Mohit Gupta signing off. Have a great day.